Hello, hello, and welcome to this video. So we have solved the problem 110 of polynomials and various equations. In this video, we will solve 10 more problems from problem 111 to 120. So as always, I'll say that when I'm stating the problem, you pause the video, and only if you cannot solve the problem, then look at the solution. So without further ado, let's get started. Question number 111 says that, oh, sorry, it's in mode. Okay. Question 111 says that solve 3x into x plus y minus 2 is equal to 2y. There is the first equation, and y into x plus y minus 1 is equal to 9x. There is the second equation. So you see, two variables, two unknowns would be easy. So we have this equation and this equation. So we multiply given equation and we get 3xy into x plus y minus 2 into x plus y minus 1. And this gives us 18xy on right hand side because we had 2y and 9x, so 18xy. We do some operations on it, and what you do is we take 18xy and bring it to the left hand side. We get 3xy into x plus y minus 1 plus into x plus y minus 2 minus 6 equal to 0. That gives us 3xy into x plus y minus 4 into x plus y plus 1 equal to 0. Now, since this equation is equal to 0, so either x is 0 or y is 0, or x plus y is equal to 4, or x plus y is equal to minus 1. So we first take x plus y is equal to 4 and put it in the first equation. So if you take x plus y is equal to 4 and put it in this equation, then this will become 4 minus 2, that is 2, that is 6x is equal to 2y. So that means y is equal to 3x. Once we have y is equal to 3x, we put it in here. We get 4x is equal to 4, that is x is equal to 1, and then y is equal to 3. Now that is for this, okay? So we have covered x is equal to 0, y is equal to 0, and this gave us x is equal to 1, y is equal to 3. Now we have x plus y is equal to minus 1. We put it back in the equation 1. So this becomes minus 1 and minus 2 minus 3. So minus 9x is equal to 2y. So y is equal to minus 9x by 2. Now once we have this, we put it back in here and we get minus 7 by 2x is equal to minus 1. So x is equal to 2 by 7 and y is equal to minus 9 by 7. So it was very easy. Now we solve question number 112. Again, we have three equations and three unknowns. We are given xy plus x plus y is equal to 23, yz plus y plus z is equal to 31, and zx plus z plus x is equal to 47. So what we do is we add 1 to both the sides of 1. So we get xy plus x plus y plus 1 is equal to 24. That is x plus 1 into y plus 1 is equal to 24. We also add 1 to the second equation. We get y plus 1 into z plus 1 equal to 32. It was 31, 32, and this will become z plus 1 into x plus 1 is equal to 48. Once we have three equations, we multiply all of them. We get x plus 1 whole square into y plus 1 whole square into z plus 1 whole square is equal to 24 into 32 into 48. So then what we do is we take the square root. We get x plus 1 into y plus 1 into z plus 1 is equal to plus minus 24 into 8. Okay. So how we got 24 into 8 is you take 6 from this guy, and that would be 6 into 48, and this would be, you take 4 from this, so 4 into 8, 38, so 6, 4, yeah, 24, that will become 24 square, and then this will have 8 into 8, that is 8 square. So x plus 1 into y plus 1 into z plus 1 is equal to plus minus 24 into 8. Now once we have this, we have the possibilities that z plus 1 is equal to plus minus 8, x plus 1 is equal to plus minus 6, and y plus 1 is equal to plus minus 4. So once you have this, you can divide from this these three equations and you can figure this out. Once we have that, we have the possible values of x, y, and z, and that is the solution of the equations. Now, question 113 says that find all the solutions of the system of equations y is equal to 4x cubed minus 3x, z is equal to 4y cubed minus 3y, and x is equal to 4z cubed minus 3z. So we look at the solution here. Okay. So if we look at this, find all the solutions. So we first consider if x is greater than 1, then y is equal to x cubed plus 3x into x square minus 1, which is greater than x cubed and greater than x and greater than 1. And z is equal to y cubed plus 3y into y square minus 1. And that would be greater than y cubed, greater than y, greater than 1. And similarly, x is equal to z cubed plus 3z into z square minus 1. Now, if this x would be also greater than 1. So if you look at all these conditions, you get a cyclic condition that z is greater than y, greater than x, which is greater than z, which is impossible. Now we take x less than 1, and again, if x is less than minus 1, then x will be greater than y, will be greater than z, it will be greater than x. So again, it is impossible. Okay. So what would be the value of x, y, z? There is a typing mistake. There should be a backslash here. Okay. So x is greater than equal to minus 1. So that means the modulus of x, y, and z will be less than 1. Now, once we have determined that modulus is less than 1, we can write x is equal to cos theta to get ourselves nice trigonometric function. Y is equal to 4 cos theta minus 3 cos theta, that is cos 2 theta. And then z becomes cos 9 theta and x becomes cos 27 theta. So since trigonometric functions are periodic, it is possible thus cos theta is equal to cos 27 theta. That is cos theta minus cos 27 theta is equal to 0. How we arrived at this is because this is x is equal to cos theta, and finally we have figured out from this equation that it is cos 27 theta. Then again from trigonometric relations we have 2 sine 14 theta cos 7 theta is equal to 0. Now this implies that theta is equal to k pi by 13. Okay. Now that means k can take the value of 0 to 13, or theta is equal to k pi by 14, where k can leave from value 1 to 13. So the solution set is x, y, z is equal to cos theta, cos 3 theta, cos 9 theta, where theta will take one of these above values. Now we move on to question 114. So what question 114 says that if let x is equal to p, y is equal to q, z is equal to r, and w is equal to s, be the unique solution of system of linear equations x plus aiy plus ai square z plus ai cube w is equal to ai4, where I is 1, 2, 3, 4. There was an extra comma. So two typing mistakes. Okay. Now, once we have this solution, we have to express the solution of the following system of equations in terms of P, Q, R, and S. Okay, there is the full stop here, there should be space. So the new system is x plus ai square y plus ai to the power 4z plus ai to the power 6 w is equal to ai to the power 8, where I is again 1, 2, 3, 4. Assume the uniqueness of the solution. So, okay. Now, we consider the equation p plus q2 plus rt square plus st cubed is equal to p to the power 4. So, p to the power 4 minus st cubed minus rt square minus q2 minus p is equal to 0. Now, we take that a1, a2, a3, a4 are the solutions of the given equation. So, we apply Vieta's relation. We have sigma 1 is equal to s, that is the negative of coefficient of p cube by coefficient of p to the power 4. a1 plus a2 plus a3 plus a4 is equal to s. sigma 2 is equal to A1 A2 into A3 A4 plus A1 A2 plus A3 A4 is equal to minus R. Sigma 3 is equal to A1 A2 into A3 plus A4 plus A3 A4 into A1 plus A2 is equal to Q, and sigma 4 is equal to A1 A2 A3 A4 is equal to minus P. Now the second system of equation which we have is, that is t square to the power 4 minus wt square to the power 3 minus zt square to the power square minus yt square minus x is equal to 0. So let's revisit this equation. There is a minus x here. Okay, this is the x1. This becomes minus x. Okay. So once we have this, we put t square equal to u. Our equation becomes e to the power 4 minus wu cube minus zu square minus yu minus x equal to 0. And then the roots would be of this equation would be a1 square, a2 square, a3 square, and a4 square. So okay, because it is given that no, it is not given. Okay. So what we are given is, sorry about the phone call. So since t square is a term here, okay, the roots will be squared, and A1, A2, A3, A4 were solution of this equation. So this will have a squared value of that. Now sigma 1 is A1 square plus A2 square plus A3 square plus A4 square. Okay, so we substitute the value what we have obtained here till now, and we have W is equal to sigma I square and subtracted with 2 AI AJ. So there is a static notation. So what this essentially means is that is A1 plus A2 plus A3 A4 whole square minus 2 into A1 A2 A1 A3 A1 A4 A2 A3 A2 A4 and A3 A4. So this becomes equal to S square plus 2R. And similarly, sigma 2 is sum, there should be a sigma here, it is missing. So sigma AI square AJ square, which is further elaborated integrations, and that is minus R square plus 2PS plus 2P, and similarly you find sigma 3, which is equal to y, and y is equal to p square minus 2pr, and sigma 4 is minus x, which is minus p square. And thus we have all the sigma 1, sigma 2, sigma 3, and sigma 4. Now we move on to question 115. For question 114, I would ask you to establish this relationship here between these roots and how they work. So establish the Vieta's relationship, which shouldn't be difficult. Okay. Now we move on to question 115. Question 115 says that find out all values of a and b for which xyz plus z is equal to a, xyz square plus z is equal to b, and x square plus y square plus z square is equal to 4 has only one solution. So what we observe in this case that xyz and minus x minus yz satisfy the given condition of equation. So if you put minus x minus y, this sign will not change, this sign will not change, neither the sign of this will change. So just from observation we have that. And since we have only one solution, we deduce that xy is equal to 0, because if xy is anything other than 0, then we will have two solutions. So now we have xy is equal to 0, we put it in the third equation, we get z square is equal to 4, z is equal to plus minus 2. So from question 1 and 2, we have z is equal to a and z is equal to b. So either a is equal to b is equal to 2, or a is equal to b is equal to minus 2. Now if a and b both are 2, we have xyz plus z is equal to 2, xyz square plus z is equal to 2, and x square plus y square plus z square is equal to 4. This implies that xyz into z minus 1 is equal to 0. So either x is 0, or y is 0, or z is 0, or z is equal to 1. If z is equal to 0 from the last equation, 0 is equal to 4. Okay, here it will become 0 is equal to 4, which is not possible. If z is equal to 1, then x, y are not 0, which gives more than one solution. So a is equal to b is equal to 2 does not satisfy the condition. Now we take a is equal to b equal to minus 2 and then we substitute, we get this, and following like above, we have z is equal to 0, and we see that z is equal to minus 2 is not possible, but what is possible is z is equal to 1, and in that case xy plus 1 is equal to minus 2 and xy is equal to minus 3, and x square plus y square is equal to 3, which implies that x plus y whole square is minus 3. So that is also not possible. So following these conditions, we see that we have only one unique solution, which is 0, 0 and minus 2. So that would be minus 2. Okay. All right, so we have this. Now we move on to question 116. Given A, B, C are positive real numbers such that a square plus ab plus b square by 3 is equal to 25, b square by 3 plus c square is equal to 9, and c square plus ca plus a square is equal to 16. Find out the value of ab plus 2bc plus 3ca. So we have these three given equations. So, okay. So what we do is we have 25 here, we put the value of 9 plus 16, which is 25. So the given equation becomes, we substitute this for the 9 and 16. So our given equation upon simplification becomes a plus 2c is equal to ab by c. And also we see that 25 minus 6 plus 16 equals 32. And we again simplify, we get 2a plus b plus c is equal to 32 by a. Now we have to eliminate ab plus 2bc plus 3ca. So we take b common, we get b into a plus 2c plus 3ca, and we have a plus 2c is equal to ab by c. So we put in here, and we get upon simplification 27a by c. But we also see that ab into 2bc plus 3ca would be equal to 2c square plus ac plus 2bc plus 3ca, which is equal to 2c into c plus b plus 2a. Now we have for this, we have 2a plus b plus c, which is equal to 32 by a. So we put in here, or we put in here rather. Okay. So that will become 32 by a, and which will be equal to 27 by c, which is this value. Okay. And into 1 by 2c. That means a square by c square equal to 64 by 27 is equal, which implies that ab plus 2bc plus 3ca is equal to 27 into a by c. And from here we get a by c, and we get final value of 24 into 3. So I have omitted a lot of steps. That's why it may be difficult to follow this solution. If you break down every step, the solution is pretty simple. Question 170 says that solve log of 2x, and then we take log 3 of log 2x. So we can read it as log of log 2x with base 3, and then we have this log of y with base half, and we take then log of that with base 1 by 3 is equal to 1, and xy square is equal to 4. So here what we do is we do base exchange here. Okay. So log 1 by 3, we take out the negative sign here, and we write it as log 3 of log y, and with base 1 by 2 is equal to 1. Once we have this form, we can get rid of log 3, and we can write log of 2x by log of half y. So once we have that, we have log of 2x is equal to minus 3 log 2y. Once we have this relationship, we have xy cube is equal to 1. Once we have xy cube is equal to 1 and xy square is equal to 4, we get y is equal to 1 by 4, and that means x is equal to 64. Easy problem. Question 118 says that solve log 2x, log 4y, log 4z is equal to 2. Log 3y plus log 9z plus log 9x is equal to 2. Log 4z plus log 15z plus log 16y is equal to 2. So again, it is very simple standard solution. We know that log of x with base a is equal to log of x to the power n with base a to the power n. So we can write that log of x with base 2 is equal to log of x square with base 4, log of y with base 3 is equal to log of y square by 9, and log of z with base 4 is equal to log of z square with base 16. So from the first equation, we have x square yz is equal to 16, and from the second, we have y square zx is equal to 81, and from third, we have 256. So multiply all those, we get xyz to the power 4 is equal to 24. Okay. So we have 16, 81, and 256. And power is 4. So this would be 2 to the power 4 is 16. 3 to the power 4 is 81. And 4 to the power 4 is 256. So 4 3 is 12. We have 24. 24 x y z, and then we have these, we divide and we obtain x is equal to 2 by 3, y is equal to 27 by 8, and z is equal to 32 by 3. Question 190 says that find all real numbers x and y that is fine. Log of x with base 3 plus log of y with base 2 is equal to 2, and 3 to the power x minus 2 to the power y is equal to 23. So if you look at this, okay, so this is 2. All right. So if we put x is equal to 3 and y is equal to 2, it will be one solution for this equation. But then we see we put x is equal to 3, so this will become 27 and this will become 24. So 27 minus 24 would be 23. So clearly x is equal to 3 and y is equal to 2 is one of the solutions. Now let's see if we can find out other solution. So if x is less than 3, then log of x with base 3 is less than 1. And since we have this equation, log of y with base 2 will be greater than 2. And then that means y is greater than 2. Okay. This would be 1 here. Yeah. So question 130, 140, 190 pattern makes sense. What we can say that once we have y greater than 2, we can say that 3 to the power x is less than 3 to the power 3. So we have here 3 to the power x. Now x we took less than 3. So this is less than 20, that is 27. And 2y will be greater than 2 square because y is now greater than 2. So that means 3x minus 2 to the power y will be less than 23. So now we have arrived at a condition which does not match with our equation because it must be equal to 23, but it is coming out to be less than 23, hence x cannot be less than 3. And similarly, we can prove that x cannot be greater than 3 because if you put x greater than 3, then y will automatically become less than 1. Less than 2. And that means 3 to the power x minus 2 to the power y will be now greater than 23. So x cannot be greater than 23. And therefore, we have the only solution which we derived by observation, that is x is equal to 3 and y is equal to 2. Now we come to the last problem of this set. We have alpha, beta, gamma as roots of x cubed minus x square minus 1 equals 0. And we have to find the value of 1 plus alpha by 1 minus gamma plus 1 by beta by 1 minus gamma plus 1. 1 plus beta by 1 minus beta plus 1 plus gamma by 1 minus gamma, which is minus. That is another typing mistake. Okay. So now we look at the solution. So we have this given equation. So from beta relationship, we can say that alpha plus beta plus gamma is equal to 1. Alpha beta plus beta gamma plus gamma alpha is equal to 0. And alpha beta gamma is equal to 1. So once we have that, we take the left hand side and we brute force it and do what we need to do. Again, here this should be 1 minus gamma. So the entire equation becomes 3 minus alpha plus beta plus gamma minus alpha beta plus beta gamma plus gamma alpha plus 3 alpha beta gamma divided by 1 minus alpha plus beta plus gamma plus alpha beta plus beta gamma plus gamma alpha minus alpha beta gamma. Simply put in the values and we get the solution as minus 5. So I think this was the easiest problem, question 120. So with this, we come to the end of another set of problems, and I hope you are enjoying this series and you're finding the videos useful and informative. And I implore you to subscribe to the channel and like the video. so that YouTube can spread this video to more users. The more people, the more the number of likes, the more the number of subscription, the more people, the more will be the reach of the video. So help your fellow students. You know why? Because sharing is good. So if you have something to eat, share it. If you have a lot of money, share it. If you have any kind of ability to give, learn to give to the society. So thanks a lot for watching the video. Enjoy.